Okay, I think we can start. Good afternoon and welcome everybody. My name is Ken Casale. I'm a technical evangelist at Microsoft Switzerland. And in the next 50 minutes, I will give you an overview on how you can architect your web solution, your web application in the cloud. Of course, in the Microsoft Azure cloud. I will start with the following slide, which you may have seen already many times. So on the left side, we have infrastructure as a service. Basically, in infrastructure as a service, you need to manage everything. So we are talking about virtual machine. You need to manage them. You need to patch them. You're responsible for those machines. And then we move on the right side. First, we met cloud services. And then on the top right side, we have app service. App service, which includes mobile apps. So basically, it's a platform for building mobile applications for any devices, any platform which offer great out-of-the-box functionality, like, for instance, offline support. We then have API apps, which are for building and consuming API. You can basically compare them like ASP.NET Web API, but with additional out-of-the-box functionality. And then what we have logic apps, which lets you create workflow that automate business processes. And in order to build those logic apps, you have a workflow designer that you can use. And then finally, we have the focus of today's presentation, which is about Azure App Service Web Apps. From now on, I will just say Web Apps, because App Service Web Apps, it's too long. Now, the first question is, why did I choose to go with Web Apps? The point here is that you should always try first with Platform as a Service. So Platform as a Service should always be your first choice. Okay? If then you have some technical problem, you can also start then considering to use infrastructure as a service. But the first choice should always be web apps. The second reason why I decided to go with web apps is because web apps today, they offer you really all you need in order to deploy a web application in the cloud. It could be a simple website, but it could be even a top international website with extremely high traffic. Web apps, they offer really a lot of great stuff with a lot of great features, and I will do my best during, during those 50 minutes to show you all those great features of this platform. Now I will start with the first demo. It's a video. For those of you who knows me, I always do live demo, but in order to spare some time, I decided to do a video and to cut all the dead time, because this is really the 5 minutes typical keynote demo that you get when you are looking at web application, and my goal is really to bring everybody at the same level. I will comment that video. So, what we do, we go on the new Azure portal, portal.azure.com. Once we are on the new Azure portal, what we do, we go on new. We want to create a new web application, so I go on new. I select web and mobile. I then select web app, because I want to deploy a web application. I need to provide a name. So my TechDays web app.azurewebsite.net. Of course, this can be changed with your custom domain. You select the subscription. You provide a resource group, rg_TechDays. The resource group, it's a way in order that you can use in order to organize your resources. Then what you do, you create a new app service plan. You provide a name. And basically, by the app service plan, you need to provide the location. Where do you want to host your application? Inside which data center? So I select the location. And then you need to provide the kind of machine that you want to use. In that case, I select a standard machine. Then your app is going to be created. And as you will see in a couple of seconds, my app will be available. So the app has been deployed. I can click now on the generated URL. And as you will see in a moment, my web app is an empty app. So now I need to deploy something. And in order to deploy something, I will use Visual Studio. So I start Visual Studio. I create a new project. I create a new ASP.NET web application project, an MVC project. I click on OK. The project is being created. Now I can compile my application, and I can go at the project level, and I can right-click on top of it. I can click on Publish. At that point, I click on Microsoft Azure App Service. I select my subscription. At that point, you will see in the low part that you will get the list of resource group available. You select your web application. You click on OK. Now an XML file containing all the connection information is being downloaded. You can choose if you want to deploy the debug version or the release version. If you deploy the release version, the debug version, you can then start a remote debugging session. Now it's being deployed on Azure. Usually it's not that fast. I cut some part, of course. And voila, we have our web application. Now what can you start to do? You can start to do some stuff. You go on Setting, and you can start to scale up your application. So basically, you are changing the size of your VM if you want. You can choose between different sizes, as you can see. And the second thing I want to do, I want to scale out my application, which basically means increasing the number of instances on which my website is being running. So at that point, I'm going to use the auto-scaling feature. I have this profile. I delete the default profile, and then add a new profile. And with the new profile, I'm basically saying that my app service plan can scale from 2, for a minimum of 2, to a maximum of 8 instances. I can also change the recurrence, set a different recurrence or a fixed date, whatever I want, but let's keep it simple. And now I click on OK. And now what I have to do, I have to define a rule, okay, which applies to the scale profile I just created. And here I'm basically telling to Azure that it has to monitor the performance of my web farm. You see, I get a list of many metrics, and in my case, I'm going to choose the CPU percentage, because I want to tell to Azure that it has to monitor the average CPU percentage of my web farm, and in case the average CPU percentage is greater than 70% during the last 10 minutes, that's the average, I want to increase by 1 or by any other number that I want, the number of instances, okay? So this is the basics, okay? I can now save, and I can in that way save my scaling rule. Now what can you do? You can also use deployment slots, which are quite useful if you need to deploy, to roll out the new version of your web app. So I go inside the deployment slot section, I click on that slot, and I want to define a staging slot. I call it staging slot. The staging slot is being created, and now suppose that you want to deploy the new version of your web application on that staging slot, okay? You're going to test your web application inside that staging slot, and when everything is finished, what you can do, you can start a swap operation. So you go on the portal, you click on swap, and you say you want to swap the source, which is the staging slot, with the production slot. You click on OK, the swap operation takes place, and when the swap operation completes, all my users will be on the new version of my web application. And voila, this was the basic demo, and I will use this demo in order to start a discussion about what we have seen so far. So let's go back to the slide. And let's start a discussion on top of that. First of all, how do you scale your web tier? We have seen we have two options. You can scale it up, meaning you can increase or change the size of your VM. That's the first option. The second option, you can scale it out, meaning you increase the number of instances on which your solution is being deployed. Okay? Those are the two options. Now I should say that the web application in Azure, those app service web app, they have been designed to be scaled out, so to change the number of instances on which you're running your solution. Why that? Because we have features like this auto-scaling feature, which is really actually about increasing or decreasing the number of instances on which your solution is being hosted. And by the way, this auto-scaling feature makes even more sense if you can have a situation in which you can have an unexpected increase in traffic. Now, we need to find out what is the best combination between virtual machine size and number of instances of those virtual machine? How can you find it out? The solution is load testing. So you need to run a load test on top of your website. How can you do that? Usually, you start by defining what we call a scale unit, and it's up to you to define what a scale unit is. So you say a scale unit could be free virtual machine, free S1 virtual machine, okay? And then you start to run a load test on top of it. You see the result. You see how many users you can reach with an acceptable response time. Let's say that you're not happy, you're not reaching enough users, so you double your scale unit, okay? So you go from 3 S1 VM, you go to 6 S1 VM, and you run again your test. At that time, maybe you're happy with the result, you're happy with the number of users that you're reaching, you're happy with the response time, so now you can start to optimize a little bit things. So maybe you can start to reduce the number of instances. You go from 6 to 5, and so on. So I'm saying that because basically there is no strict rule. It really depends on the kind of application that you have. So it's really up to you to run a load test on top of your web app, because maybe you have a web application which is really memory intensive, CPU intensive. Maybe you have a web solution which is more database intensive. And then maybe in that case you're not going to use a really strong machine, okay? So it really depends on each different situation. You will have a different thing. Now, in this regard, in regards to load test, I think it's interesting to mention that inside the new portal, if you select your application and you click on Tools, you can now click on Performance Test. It's a new integration, it's pretty new. So you can basically start a load test inside your web application. You just click on Tools, Performance Test, and the nice thing about that is that you get this nice integration. Basically, it is going to create for you a Visual Studio Team Services account if you don't have one already, okay? And it will create a load test for you. By the way, we are giving to all users a free monthly credit that you can use in order to run your test, of course with some limitation. But at least you can try out that nice feature. Let's continue. One of the good practice, let's say, it's always to keep the web tier stateless. And with stateless, I mean that the general rule should always be not to store application data inside the web server memory or the web server file system. Why that? Because the server may fail, okay? Maybe if you need to scale out your web solution and you're using session state, you may have a problem, because by increasing the number of instances, you have the following situation. You have the user, which is making the first request. The first request of that specific user is landing on a specific server. The second request of the same user may land on a different server. And so you have a problem if you're using session state. Of course, if you know already web apps, you know that web apps inside Azure, they are pre-configured with session affinity. It means you will never find yourself in the following situation. It means that all the requests of the same users are going to land always on the same server. But I would say that it's a bad practice to do that. So my suggestion is to say, use an external storage, which can be shared across all the instances, and avoid session affinity. So disable session affinity by web apps. How can you do that? I put the link there. It's pretty easy. You just need to add a couple of lines inside the web configuration file. And you can disable session affinity by web apps, which is per default active, pre-configured. In general, I would say that you should really try to store the data in some kind of redundant storage, which is available, which can be shared across all those instances. And so, in regards to session state, if you really need session state inside your application, Microsoft recommends you to use Azure Redis Cache, which is our dedicated high-performance cache. And in regards to session state, together with Azure Redis Cache, we have a Redis Cache session state provider for ASP.NET application. So you can go on that link, so the last one, the last two actually, and we are showing you how you can easily integrate session state inside the Azure Redis cache inside your ASP.NET application. We have also a provider for the output cache, and this is the last link. This redundant storage, where you can put information that can be shared across all those instances, could also be Azure Blob Storage. And in the Azure Blob Storage, you could put some files, some assets, and typically you put images, like a JavaScript file, CSS file, and especially you put information or files which can change quite frequently, because if the information is changing quite frequently, if you're not using like an external storage like Azure Blob Storage, then every time you need to change something, you need to repackage your application, including those files, and you need to redistribute that package on all the running instances. So the suggestion is really to put those kind of information inside the Azure Blob Storage. There is another thing that you should consider. If you're using Azure Storage or Blob Storage, you should also consider to use CDN, Content Delivery Network, especially in the case you don't have just local users, but your users, the users of your web application, are spread across different countries. So you can make use of CDN, Content Delivery Network. And here I should add that since Microsoft announced the partnership with Akamai, very, very soon, I can just say that, you will see the offer Akamai integrated inside the Azure offer, and so I would say that at that point, we will probably have the best content delivery option for our customer. So consider that, consider using CDN as well. Now, improve the availability of your critical web application. How can you do that? You can do that by using the Azure Traffic Manager. And there are many reasons why you should use Azure Traffic Manager, okay? Suppose that you have your web application, and you have your web application which is deployed in different locations. Different location could be a different Azure data center, but could also be your on-premises location, could also be a different cloud provider. Hopefully not, we always hope that you stay on Azure. But anyway, you never know, okay? So Traffic Manager supports all those scenarios. And then with Traffic Manager, you basically can control the distribution of the user traffic across all those different locations, okay? And you do that by using policies. And here we have different kinds of policies. We have performance policy, which basically are going to redirect user requests to the closest location. So in case I'm an American user, my request will be redirected to the American data center. I'm a European user, my request will be redirected to the European data center, and so on. We then have the failover policy, and here I should say that although the loss, okay, of an entire region, it's an unlikely event. Anyway, if you have some critical web application, I would think about to integrate that policy as well. And by the way, you can also combine those policies. We talk about nested profiles. So you can combine the performance policy together with the failover policy. And with the failover policy, you're basically saying, this is my first data center. All the request has to be sent to that specific data center. If that data center is not available, try with the second one I define on the list. If the second one is not available, try with the third one, and so on. We then have the round-robin policy, okay? And with the round-robin policy, we are actually equally distribute all the requests across all the locations, okay? And by the way, here I should mention something new, an additional tip around round-robin. It's a new feature we introduced in the last month, which is that round-robin now support weighted distribution of traffic. What does it mean that? It means that you can basically redirect a small percentage of your traffic to a separate deployment, okay? Now think about, if you need to deploy the new version of a critical web application, okay? By using this round-robin weighted distribution of traffic, you could say, I want to now, you did all your tests, let's say that you're really ready to go into production. With this feature, you can say, I want to now redirect just 5% of the traffic to this new deployment of the production load, of the production traffic, okay? And you see, okay, everything looks good. Then let's move 10% of production load. Everything good, 15, and so on, until you get up to 100%. And at that point, all the users will be on the new version of your web application. Deployment consideration. During the first demo or during the video, you have seen I was creating a deployment slot, and I told you that it's quite useful if you need to roll out a new version of your web application. But now I think it's really important to understand what's happening actually when you're clicking on that swap button, when you're doing a swap operation. And basically, what's happening is the following. Basically, the settings that are marked inside the configuration site as slot settings are read from the production slot, and they are applied to the staging slot. When this operation is happening, the worker process of the staging slot will be restarted. It means there is a cold start activation. For this reason, as a second step, as Microsoft, when you do the swap operation, what we are doing, we need to warm up the site in the staging slot. And in order to do that, what we do, we are basically sending an HTTP request to the root directory of your web application. And then, when your web app is warm, when your web application in the staging slot is warmed up, we can complete the swap operation. Now, there is a but. The problem is that maybe you have additional URL path that needs to be warmed up. And we are just sending an HTTP request to the root of your web application. So you may need to warm up additional routes of your web application. Second, you may have to pre-populate the memory cache. So in order to solve this problem, we introduced in the last time a new feature which is called Swap with Preview. So basically, with the Swap with Preview feature, you do exactly the same thing up until action number 2. So we are still sending the HTTP request to the root of your site, to the root of your web application. But then, so you basically go here, you select swap type, it's swap with preview from staging to production. And then, now you have the time yourself to go and verify the website in the staging slot and verifying if this website in the staging slot is working well with the production setting. So you can really go, you can hit different URL paths of your web application so that your application gets warmed up in the proper way because you know what you have to do. You can make in a way that the memory cache is being pre-populated and so on. You can do all the last check, and then you go back in the portal, complete swap, swap action, complete swap. If you're not happy with whatever reason, you can always click on cancel swap. In which case, you reset the settings on the staging slot as they were originally. Last thing, don't use deployment slot for load testing. Why that? Because deployment slot, they are living on the same virtual machine where your production slot is living. So if you're running a load test, you will have an impact on the performance of your production application, okay? Performance consideration, I think it's good to mention that there is this tool, no time for the demo. You click on that link and you will see you can do some latency test from your location to different Azure data center. So you see the latency of the Azure storage. You can do an upload test, a download speed test. You can do as well, I think, a CDN test. It's good to know that there is this tool available in order to determine for you which is the best data center in your case. Now, let's start to go a little bit deeper. So far, I was doing more general consideration. Let's go a little bit deeper about talking about architecture, what you should consider, which component could you use in case you want to create a web application. And in case you want to start to integrate some stuff, you should think about using web jobs. What are web jobs? For those of you who don't know what web jobs are, So basically, a web jobs, it provides you an easy way, and I repeat, an easy way to really run some script or some program as a background process in the context of the web application. We support different type of executable, exe, bat, Python script, PowerShell script, many stuff. If you want an exe, you create a .NET console application. So pretty easy. So as soon as you need to run something in the background, start to think about web jobs. Maybe you need to process some stuff asynchronously. Maybe you need to do some CPU-intensive stuff in the background. Think about the job. Maybe you need to process some files which have been uploaded inside the Azure storage, and then you need to do something with those files asynchronously. Think about web jobs. Maybe you have an e-commerce website, okay? And let's say that you have the users which is creating an order, okay? When I create the order, I could design my application in the following way and say, when the customer click on create order, I will create a message inside an Azure storage queue. And then there will be a web jobs which will pick up that message from my message queue, and it will process the order asynchronously for me, because you don't want to make user wait on your website, okay? This could be a possible scenario where you could use web jobs. Maybe you wanted to clean up some stuff, clean up some log file, whatever. Think about, again, web jobs. We have 3 different types of web jobs. On-demand web jobs, so they are triggered on demand. On-schedule web jobs, they are triggered based on a schedule. But then I would say the most interesting one are probably those continuous web jobs. Continuous web jobs, they're running all the time, okay? And those continuous web jobs, you have to know that when you scale out your web tier, meaning you increase the number of instances on which your solution is running, also the web jobs which is running inside the same machine, inside the same context of your web application, will also scale. So you will have as many instances of web jobs running as your app, the same. But of course, maybe you have some situation in which you don't want to scale the number of web jobs where your job is running. No problem, you can configure a continuous web jobs as a singleton web jobs. It means that if you start a scale operation, you increase the number of instances on which your solution is running, the web jobs will just run and stay on one single instance. You can configure that, no problem. Writing a web jobs, I mentioned before, it's really easy. I suggest you to have a look at the following link. It's plenty of resources, plenty of sample. But now, anyway, I don't have a lot of time, but anyway, I prepared a slide in order to give you an idea of the power of web jobs. And when you are dealing with continuous web jobs, it can be quite useful to deal with trigger and binders. And in order to understand trigger and binders, I prepared a couple of samples. So the first method is basically a method which is being triggered whenever a new blob is being created inside the input blob container, okay? That's why we call it, that's why the first attribute is called a blob trigger. So my method is being triggered as soon as a new blob is being created inside the input container, okay? And then the same blob, which is represented in our case by the object output parameter, yes, with the same main, the blob is being created inside another container called output container. The second method is showing you a sample of a queue trigger. So we have blob trigger and queue trigger. And the second method, instead of being triggered, it is being triggered as soon as a new message is being created inside the message queue called initial order, okay? And in that case, the message itself is being represented by the order object. It is being automatically deserialized for you, so you don't have to do anything. And the blob containing the order details is then being created. So you see, just by using those attributes, you can do quite a lot of stuff. As I said, I suggest you to have a look at the link on the previous slide. You will find out quite a lot of useful information. In addition to those two methods, you just need to add a couple of lines of code, okay, and a couple of lines inside the application configuration file of your console.NET application, and you are done. That's the whole code that you need to write in order to do something like that. So pretty easy to use, pretty powerful. Now some final consideration around web jobs. In case you have a web jobs which is really requiring a lot of resources, you should think about deploying that job on a separate empty web application dedicated to him, okay? That's a good idea to do. Otherwise, you're going to have an impact on the performance of your web application. Because remember, they're running inside the same context, on the same machine. Now, the nice thing about those web jobs, I mentioned it before, if you do a scale operation, well, we will increase as well the number of web jobs on which we have our background code, let's say. And now suppose that you have the following situation. The situation I was mentioning before with our eShop application. The user is creating an order. The order is being stored inside the storage queue, okay? And then we have 3 web jobs which are waiting for new orders inside that storage queue. I scale up my web jobs, and now I start to think about, what's happening now? Is there any risk that the same message will be picked up at the same time by 2 different web jobs? No, it's not possible, because everything is being managed by web jobs. So you don't have to be scared of this specific scenario. Okay? So one message will just be picked up by a single web jobs. So you see, once again, you don't have to write any line of code, and you get all this great functionality out of the box. Think about if you need to implement something like that by yourself. You need to start to put some blocks on the messages and so on. Here it's being managed everything by web jobs. Another cool feature that you have, web jobs are coming with a retry mechanism built in out of the box. So if for whatever reason a message can be processed, there is an exception, whatever, the web jobs will retry to reprocess the same message one more time, and one more time, and one more time. There is a configuration value that you can change. Per default, I think it's 5, but you can change it. So for 5 times, it will retry and retry and retry. In case, after the 5th time, there is again a problem, he will take the message and he will put the message inside a message.dat queue. So also here, you don't have to do anything. It's all out of the box provided to you. And then you should also know that we provide to you a dashboard which is being created, which is being available inside the new Azure portal. And with this dashboard, you can really monitor your web jobs. Is my web jobs running? When did my web jobs run the last time? Do we have any problem with our web jobs? And so on. So quite a lot of functionality out of the box. Now, last thing about web jobs, one thing that you may not be aware of, during the first demo, during the video, you have seen I was defining the scaling rule. And I was saying, in case the CPU usage is greater than whatever, please start to increase the number of instances. But what I was doing, I was basically monitoring the app service plan. So basically the web farm where my web application is running. In case you have the following situation of the eShop, what you can do, you can tell to Azure, instead of monitoring the machine on which my solution is running, you can tell him to monitor that specific queue. And you can tell him you should increase or decrease the number of web jobs instances by monitoring the number of messages which are being inserted inside my queue. Because this is actually what my job is doing. It's actually picking up messages from my queue. So it will scale my web jobs based on an external factor, which is the storage queue. It's good to know that you have this option available. Of course, in that case, I should deploy what I mentioned before, the web jobs on a completely separate, empty web application, and not on the same web application when your solution is running. Okay, so otherwise you have a conflict within the two. Last point, explore the web jobs SDK to discover additional trigger. With that, I mean we don't have just queue trigger and blob trigger, but we also have other triggers. You can discover them. The link is on the other slide. And now let's start to do a step back and let's go a little bit deeper inside the architecture of our web application. So during the video, during the first demo, what I did, I created a new web application. So I went to the portal, web and mobile, web app. I provided a name of my web app. I said that I want to create a new app service plan. With the app service plan, I said I wanted to deploy my web app in the West Europe location, and I want to use an S1 machine. This was the first demo. Now, if I try to represent what I did during the first demo with a schema, I would probably design everything in that way. I would probably say, okay, we are in the cloud, Microsoft Azure, then we have internet. Don't blame me, of course, internet is bigger than the cloud, but it's just a schema. Then what we did, we deployed the front end, and we deployed that in form of a web application. A web application which is communicating with the outside, okay? Then I talked quite a lot about increasing and decreasing the number of instances on which your solution is running. So I can say, I want to go to 2 instances, or I want to go to 3 instances. I changed the last icon just to remember you that you can always have maybe a web jobs running on one single instance. Do you remember? I told you you can use the singleton configuration. Now you may need an Azure storage. You may need a SQL server, in which case I would recommend to use as first choice, if possible, the SQL database, our platform as a service offer. And then you may also need an Azure Redis cache, maybe in order to store the session state. This is our recommendation as Microsoft, or just in order to improve the performance of your web application, okay? Everything good? But now let's start to think, what about if you want to deploy a web application that requires really high, very high scale? Maybe you wanted to go up to 50 instances. What about if you want to deploy your web application in a completed, isolated environment? And I will come back in a moment around this completed, isolated environment. What about if you want to secure your web application? What about if you want to control the inbound and the outbound traffic of your web application? What about if you want to access your corporate resources, an internal database, an internal web services, whatever? In order to solve that, you can use the new app service environment. How many of you have heard about app service environment? Not many, okay? It's something we launched at the end of October, so it's pretty new. But now that we have app service environment, you can really change, evolve, improve the architecture of your web application. First of all, let's see how you create an app service environment. And the app service environment is this completed, dedicated, isolated environment where you can deploy your web application. Let's see first how do you create it. It's pretty easy. You go in the portal, you click on New, you search for App Service Environment, you click on Create. Then you will land on the following mess. And the first interesting thing to note is this green square, which is telling you the creation of your App Service Environment will take you a minimum of 2 hours to complete. First of all, it's a lie. It's taking less, okay? Actually, I would say that today we are about 80 minutes, so a little bit more than 1 hour. It's taking such a long time because it's a completed, dedicated environment. Now, when you create an app service environment, you have to, it's a must, you have to create a virtual network. I call it my VNet. With a subnet, I call it subnet-ASE, app service environment. And this is the subnet where my app service environment will be deployed, okay? Then you move on the other mask, and here you can see that we have many more scaling options available. And now, I mentioned already many times that with app service environment, you get a completed, dedicated environment. And now things start to be a little bit strange. Why it's a completely dedicated environment? Actually, when I did the first demo, I was selecting an S1 machine. And this is actually a dedicated machine. So what I'm talking about? The point here is that the app service environment is introducing the concept of front-end pool. And the front-end pool represent basically a pool of virtual machines which are responsible for the first hit in the cloud for the HTTP, for the first HTTP request, if you want, for the application collection load, for the HTTP load, okay? And this is new. It exists just by the app service environment. So if you're not using the app service environment, the front-end pool concept doesn't exist. It doesn't exist. Why that? Because the front-end pool, in practice, it is being shared across all the customers, okay? Since we have introduced the concept of the front-end pool, we now need something to host your application code. And your application code will be hosted inside the worker pool. So we have 3 different worker pool 1, worker pool 2, worker pool 3, okay? And for each of those worker pool, and from the front-end pool as well, you can choose a different VM size. By the worker pool, you can choose between P1, P2, P3, P4. By the front-end pool, you can choose between P2, P3, P4, okay? Now, by the worker pool, why do you have, or do we have 3 different worker pools, and why can you choose different sizes for each one of those worker pools? Because maybe you have some web application that requires really strong performance, and so you're going to put those applications on a worker pool which has some specific virtual machine of a specific size. Then maybe you have different kind of application which does not require that much performance. You're going to put them or assign them to a different worker pool, which has less powerful machine, okay? Maybe you can say, I use worker pool 1 for my production load, maybe I use worker pool 2 for my development load, and so on. It's up to you to decide what you want to do. Now, the second question is, should I scale the front-end pool, or should I scale the worker pool? You see, you can scale them independently, okay? And here you can go up to 50 instances, more or less. So should I scale one or the other? Once again, the answer is, it depends. It depends a lot on the kind of application. If you have a large number of requests for a pretty simple web application, I would probably scale out the front-end pool. If you have not that much number of requests or light traffic, but do you have CPU-intensive, memory-intensive application, then I will probably scale up the worker pool, okay? Now, we have seen how you can create an app service environment. You wait a couple of hours or 80 minutes, and then you're ready to deploy your web application inside that web application, inside that app service environment. What you do, as before, create a new web app, you provide the name, you create still the app service plan, and at that point, when you create the app service plan, you need to select a location. And instead of selecting one of the data center, you select the app service plan you just created, okay? And then you assign your web app to one of the available worker pool. You can also just create one worker pool. You don't need 2 of them. You can just use one if you don't. Now, let's go back to our original architecture slide. This was the original situation, but now we have the app service environment. Let's try to integrate the app service environment inside that schema. First of all, we have seen that when you create an app service environment, you are required to create a virtual network. So in dark blue, we now have our virtual network. We have here our front-end subnet, ASC, where I will deploy my app service environment. So this will be our front-end, if you want. And then, since we have a virtual network, we can start to add additional subnet. So in my case, I can say I want to add a subnet for my mid-tier and a subnet for my backend tier. On the mid-tier subnet, I could deploy an additional app service environment if I want, or something else. On my backend subnet, I could deploy a SQL Server virtual machine if I decided to go with infrastructure as a service. If I don't want to go with SQL Server virtual machine, I can always go from the mid-tier up to SQL database, which is our platform as a service offer. Absolutely possible. SQL database, which is, of course, outside of our virtual network. Now, since we have a virtual network, we can now connect our VNet to what? to our on-premises location. And you can do that using a site-to-site VPN connection or an express route connection. What is express route? Express route is basically a private connection between your location and the Azure data center. Microsoft has partnership with telcos, with other partners. So we have basically a private line between the telcos location and the Azure location. You then have to connect yourself via private line between your location and the telcos location. In that way, you have a private line. Of course, it costs something, but you have quite a lot of advantages. You don't go over the public internet, as it is the case by site-to-site connection, and you can get up to 10 gigabit per second at the speed level. You can require as well an SLA on the network of an uptime SLA, okay? And then much more performance, low latency, of course. By site-to-site VPN connection, we say that usually we are between, I think, 80 and 100 megabits per second as speed. So this is the thing. Next, now that we have a virtual network, what we can do, I told you before, we need a way to control the inbound and the outbound traffic of our web application. So now you can start to use network security group. And with network security group, those network security group, they can be applied at the subnet level or to a virtual machine directly. So in my case, what I say, the traffic between my front end and the internet is basically allowed. Then I say that the front end, he can talk to the mid-tier. And I say that the mid-tier can talk to the back-end. I also say that the back-end is allowed to talk to my on-premises location. So far, so good. And now I say that the front end doesn't need to talk directly to the backend because he has to go through the middle tier. So I block down that communication path. Then I say that the backend and the mid-tier, we don't want them to talk to the outside, to the internet. So again, thanks to those network security group, you can block down this kind of communication. Let's do another step. I want to integrate a web application firewall. Maybe, I don't know, you have a Barracuda web firewall, so you need to integrate that. First of all, what you need to create an additional subnet inside your virtual network. Inside my subnet, what I do, I'm going to deploy my web application firewall in form of a virtual machine. So again, you see you have a mix between platform as a service and infrastructure as a service. We are talking about mixed kind of solution, okay? And I'm going to deploy 2 virtual machines. Why that? Because I need to guarantee the high availability of my web application firewall. This is written inside the service level agreement that you get from Microsoft. If you're using a virtual machine, you always need to deploy 2 virtual machines. So we do that, and now thanks to the application firewall, I can start to inspect the inbound traffic, detect if there are any SQL injection attack, for instance. The Barracuda firewall is doing exactly that. You can start to inspect if there are any kind of other attacks that may have an impact on your web application. Now, of course, you need to change the network security groups accordingly, the rules, those inbound, outbound rules. And now the question is, where do you find the web application firewall? The web application firewall, like the Barracuda, is part of an ecosystem of network virtual appliances, which are available inside the Azure Marketplace in form of virtual machine. And these appliances perform basically specific network function. And here the goal is really to improve, it's really to complement Azure capabilities in areas of security, WAN optimization, and so on. So we have many network virtual appliances, and those appliances are available once again in the Azure Marketplace. Where can you find the Azure Marketplace? It's being nicely integrated inside the new Azure portal. You click on New, you click on Marketplace, and then you can start to search for your own solution. I say Barracuda, and you see you get quite a lot of solution. You select your VM, and you deploy it inside your subnet. Now, I prepared a couple of slides with quite a lot of references. I put in green those 2 which I find are probably the most interesting, with quite a lot of information around architecting your web application using the app service environment. I provided a second slide with references around networking. There is also the thing about user-defined routing. Have a look at that. I didn't have the time to talk about that, but it's also useful in order to even more secure your web application, your networking infrastructure. Then a couple of slides more. If you deploy a web application, it's good to know that we have a couple of useful services you should make, or you may consider to use. The first one is Visual Studio Application Insight, which basically, it helps you to monitor the usage and the performance of your web application. So you can get information about server-side performance counter, about the response time of your web application. Basically, it helps you to monitor the usage and the performance of your application. You can define some alerts and saying basically, maybe if the response time is greater than, I don't know, 35 milliseconds, please send me an email, all out-of-the-box functionality that you get. We then have another new service, which I think is pretty cool. It's also in preview. It's called the Azure Security Center, which provides you basically visibility and control over your Azure resources. So it helps you, for instance, to detect if there is an attack, to identify attacks that it's occurring on your web application that otherwise you may not realize it's happening. And then we have Azure Resource Health, and the Azure Resource Health is basically a service that we give you as a customer in order to reduce the time that you invest in troubleshooting, in finding out where the problem is. So if you have a problem in your web app, you want to understand, is the problem caused by my own application, or is it caused by an external factor which is not part of my application? Azure Resource Health, it's here for this purpose, and it provides you really guidance and tools how to solve your problems. Additional services you may consider, if you need to integrate some sorts of identity management, there was the talk of Vittorio before, you've seen, consider using Azure Active Directory. And in particular, I want to mention two new features we announced in the last month, which are really pretty cool. Unlikely I don't have the time. Anyway, those two features are called Azure Active Directory Business to Business Collaboration and Azure Active Directory Business to Consumer Collaboration. Business to Consumer, it's about managing social identities, so Facebook, Google, Microsoft account, and so on. And I really strongly suggest you to have a look at those two Channel 9 videos, just 10 minutes each, so that you really get an idea of the power of those two services. They help you really to solve quite a lot of problems. One last slide I want to mention. I didn't talk about databases, but in many customer discussion, you have the topic of multi-tenancy. How do you deal with multi-tenancy when you're working with a database? And here I want to mention that if you're using SQL database, it means our platform as a service offer, we now have this elastic database feature, which is really cool. It really manages everything for you. So you may have a multi-tenancy solution where you decide to have one database dedicated for each customer, or you may decide to have multiple your customer, on the same database, so with sharding and all this kind of stuff. With Elastic Database, you get everything out of the box. Let's say that you have more databases, more customers on the same database, and you start to see that one of your customers is starting to use it too much resources on that database. You can decide to move that shard, that tenant, on another machine, and everything is done automatically for you. You don't have to write one single line of code. There is also this Elastic Database Client library, which is really a cool client library that you can use in order to open the connection with the backend database. Basically, with one line of code, you say, okay, I wanted to connect myself back to this Elastic pool database. This is the tenant ID, so the ID of my customer, and he will manage everything for yourself. It will open the connection with the right database, where the database of your customer is living. With that, I am at the end of the presentation. I hope it was pretty useful. If you have any question, of course, I am available for the rest of the day. Otherwise, enjoy the rest of the conference, And yeah, thank you very much.